Now, according to the U.S. Census Bureau, the world population reached 6 billion people on July 18, 1999, and is growing exponentially. By the end of the year 2000, the population had grown to 6.079 billion. The projected world population in billions of people 2 years after 2000 is given by this function. And we're going to use that. So our f of x, so I don't forget, our f of t is 6.079 e to the 0.0126t. Based on this model, what will the world population be in 2015? Well, 2015 would be 15 years after 2000. So this is f of 15, really, is 6.079 e to the 0.0126 times 15. It's time to grab that calculator, and we'll find out that the world population in 2015 is projected to be 7.344 billion people. Are you feeling crowded? When will the world population reach 8 billion then? So we're still using that same equation. F of t equals 6.079 e to the 0.0126t. And we want it to reach 8 billion, so we'll have 8 equals 6.079 e to the 0.0126t. And we're solving for t. So divide by the 6 and 79 thousandths, 8 divided 6.079 equals e to the 0.0126t. Take the natural logs of each side. So the ln of 8 divided by 6.079 equals 0.0126t. So t ends up being the ln of 8 divided by 6.079 all over 0.0126. When I grab my calculator, that turns out to be 21.8. So adding that on to the 2000, the world population will reach 8 billion in 2021 and 8/10 of the year. If you'd like to calculate that, 9.6 sometime in October, probably. Now, this is radioactive decay. It's a decay, so our K is going to be less than 0, but we don't know what it is. If 600 grams of a radioactive substance are present initially, and 4 years later only 400 grams remain, how much of the substance will be present after 6 years? Well, in my formula, y equals y sub 0 e to the kt. K is going to be negative, but we don't know what it is. So let's use the numbers we have. We have 600 initially, that's my y sub 0. E to the k we don't know. This is 4 years later, so 4k. We had only 400 left. So that's the equation we're going to use to find k. Divide by 600, I'll have 2/3 equals e to the 4k. Take the ln of both sides. So ln of 2/3 equals 4k. So k equals the ln of 2/3 divided by 4. Will caution you, do not just wait till the final thing to put this all in the calculator. Do not do any calculations along the way. It rounds things off when your numbers end up a little bit off. When you put that in your calculator, you'll find out that K equals negative 0.1014. Now we're going to go back and find out then for 6 years. Still using the same formula, but now I have some numbers filled in. I'm looking for after 6 years. I started with 600 grams. E, my K, is negative 0.1014, and my time is 6 years. Now I can use my calculator and find out that there will be 326.5 grams left of this substance after 6 years of decay.